Dear students, I think all of you are safe at home. Because of this pandemic COVID-19, you cannot attend the regular classes, but online classes starts from September 1st. Therefore, we make these videos, and you are in 5th semester for Karnataka University, Dharwad. For 5th semester mathematics, there are 3 papers. Up to 4th semester you have studied only 2 papers, but now there are 3 papers, and total number of marks is 80, 80, 80, 240 plus 60 marks internal, total 300 marks. Now, paper 1, it consists of 3 topics. Paper 1, first is Riemann integration. Riemann integration, first topic, and it is about 20 hours topic. It is 20 hours. Second is improper integrals. Improper integrals. And third topic is beta gamma functions. Beta gamma functions and multiple integrals. Multiple integrals. And application of multiple integrals is also there. Total 20 hours. And this is 20 hours. Total one paper is 40 hours. Now, improper integrals means it is the extension of the study of Riemann integration. Beta gamma functions are also improper integrals. There are 2 types of improper integrals. Multiple integrals means you are supposed to study double integrals, triple integrals. How to calculate, evaluate double integrals, and triple integrals. How to evaluate, and what are the application of this double and triple integrals? Briefly, we can I can say that syllabus is only this much: Riemann integration, improper integrals, beta gamma functions, multiple integrals. First paper. Now, I start with this Riemann integration. This is only for your reference. And if you go through this video, you can easily understand the topic, but the notes will be provided for you, and you will be supplied the detailed notes. I will give that detailed notes, full paper, full notes I will give. Now, to start with Riemann integration, in elementary calculus, you have studied integration. How you have studied integration? You have studied integration as the reverse process of differentiation. That means if d by dx of pi of x is equal to fx, suppose pi x and fx are any 2 functions, then pi of x is integration of fx with respect to x. You have studied integration as a reverse process of differentiation. But however, the origin of integration is to find the area of plane regions. Actually, the definite integral is invented first. And definite integral a to b f of x dx, this represents area. What type of area? Area bounded by the curve. Its equation is y is equal to fx, and the 2 ordinates x equal to a, x equal to b, and x axis. Definite integral a to b fx dx represents this area, and this a to b fx dx is defined as limit of a type of sum. It is purely treated as arithmetic, and the first satisfactory or rigorous treatment of this definite integral as arithmetic. A type of limit of a sum is given by Riemann. And in this topic, we start with definition of this definite integral as arithmetic given by Riemann. Then some properties of these integrable functions. Then algebra of integrable functions. And then two mean value theorems. And some problems on this Riemann integration. Now this is the Riemann integration. What is Riemann integration? Riemann integration means the definite integral is it is purely treated as arithmetic. Actually the historical order is like this. Definite integral is invented first, then indefinite integral, then derivative, differentiation. But now we study in this order, derivative integration as inverse process of differentiation. But historical order is the invention of integration is it is invented like this. It is defined as purely arithmetic, and that limit of a sum is used to calculate the area under the curve. And Riemann has given the first satisfactory treatment of this definite integral as arithmetic. Now to define what is Riemann integration, we start with this. I explain the definition of Riemann integration. For that it requires some basic ideas. First thing is, suppose fx be a bounded function. Fx be bounded function in closed interval AB. This is the notation for closed interval. Bounded in closed interval AB. What do you mean by fx is bounded? Fx is bounded means for all x belongs to AB, fx is greater than or equal to k, smaller than or equal to capital K. For all x belongs to A. Then we say that fx is bounded. Suppose fx is bounded in closed interval AB. Now we divide this AB into finite number of subintervals. AB is one interval. We further divide this into finite number of subintervals by this division. I take D is equal to A is x0, x1, xr minus 1, xr, xn coincides with B. Suppose D is any division of AB. That means this AB is divided into this number of subintervals x0, x1, x1, x2, x2, x3, etc. xr minus 1, xr, and so on, xn minus 1, xn. See, AB is divided into n number of subintervals. Now we take this rth subinterval, xr minus 1, xr, it is rth subinterval, it is denoted by delta r, and its length is also denoted by delta. What do you mean by length? xr minus 1. So we have divided AB into n number of subintervals. Now suppose small mr, capital Mr be the bounds of fx. Bounds of fx in delta. Small mr is lower bound, capital Mr is upper bound of fx in delta. Now we set two sums like this. Capital S is capital M1 delta 1 plus M2 delta 2 plus so on plus capital Mr delta plus so on Mn delta n. So we consider a sum here. What is this? Capital M1, M2 all are upper bounds. M1 is upper bound in first interval, M2 is upper bound in second subinterval, and so on. Now this is sigma r is equal to 1 to n capital Mr delta capital S, and we denote this sum by small s. What is that? M1 delta 1, M2 delta 2 plus so on, small mr delta plus etc. small mn delta L. And this is in terms of sigma notation, 1 to n small mr delta. Say we have divided AB into n number of subintervals and we have taken two sums here, capital S and small s. Now this capital S is called upper sum. Upper sum. Small s is called lower sum. Upper sum, lower sum of fx in the interval AB, and due to this division D. Division D. Now, first of all, we prove that this small s and capital S, they are bounded. We prove that small s, what is small s? Lower sum. Capital S is upper sum. This is one division. We consider different divisions, and according to or due to this division, different divisions, we will get different S and capital S. Small s and capital S. Lower sum and upper sum. These set of all these lower sums and upper sums, it is bounded. First important thing. Capital S and small s, they are bounded. See, while before defining what is Riemann integration, Riemann integral, we require all these things. Capital S, what is capital S? Upper sum. Small s is lower sum. And upper and lower sums are defined like this. Upper sum, lower sum. Now, this is first result, it is, we prove that this capital S and small s are bounded. Or in fact, we prove that this small s is greater than or equal to small m into b minus a, less than or equal to capital S, less than or equal to capital M into b minus a. Suppose small m and capital M are bounds of this fx in the interval AB, complete interval AB, then we prove this. What does this imply? Set of all small s and capital S are bounded. To prove this, we consider small m, we consider the interval AB, we divide AB into finite number of subintervals as here, as we did here, and small mr and mr be the bounds of fx in delta R. Then we have small mr less than or equal to capital mr, less than or equal to m, greater than or equal to small m. What is the reason? Because small m is lower bound of fx in the entire interval AB. Interval AB. Capital M is upper bound of fx in entire interval AB. But what are capital mr and small mr? They are the bounds of fx in some subinterval. See, in this subinterval. Therefore, obviously, this capital mr is less than or equal to m, and small mr is greater than or equal to m. Now, we have this in the beginning. We start with this. Small mr is greater than or equal to m. Capital M is greater than or equal to mr. This is upper bound in some R subinterval, and it is lower bound. Capital M and m are bounds of fx in the entire interval AB. Now we multiply by delta. M delta less than or equal to mr delta, less than or equal to mr delta, less than or equal to m delta R. What is delta? Delta R is xr minus xr minus 1. And it is positive here, this delta. So, if we multiply by delta, inequality is, it doesn't affect inequality if we multiply by delta. Now we take sum. Sigma n delta less than or equal to sigma mr delta less than or equal to sigma capital mr delta less than or equal to sigma capital M delta. M? Constant it is. Capital M is constant. So I write M sigma delta less than or equal to sigma MR delta less than or equal to sigma capital MR delta less than or equal to capital M into sigma delta. What do you mean by sigma delta? Delta is length of the arc subinterval. So sum of the subintervals is sigma delta. What is that? B minus A, length of the subinterval. Less than or equal to, what is this? This is small s. We have defined small s by this. Small s is defined like this. What is this? Capital S. Because MR is the upper bound. And it is equal to capital M into B minus. So what is this result? What does this indicate? Suppose capital S and small s are upper and lower sums, then the set of all upper sums and lower sums are bounded. They are bounded. Very important result it is. May be asked in the examination for 2 marks. Prove that this set of all upper and lower sums are bounded, or directly it will be given like this. If capital M and small m are bounds of fx in a closed interval AB, prove that M B minus A less than or equal to small s less than or equal to capital S less than or equal to capital M into B minus A. Now, this we have proved that this set of all upper and lower sums are bounded. Now, we define what are upper and lower integrals. Upper integral. What is lower integral? Now what is capital S? Set of all upper sums. This set of all upper sums is bounded. Now the infimum of set of all upper sums is called upper integral. Upper integral of fx over interval AB. See the definition. Suppose fx is bounded in a closed interval AB, capital S be the set of all upper sums, then this set of all upper sums is bounded. Now infimum of this S, what do you mean by infimum? We have studied what is infimum, supremum and so on. Infimum means it is greatest of all the lower bounds. Supremum means least of all the upper bounds. Infimum S is upper integral of fx over AB, and it is denoted by a to b bar fx dx. Remember the definition is like this. Suppose capital S is set of all upper sums. What do you mean by upper sum? Upper sum means capital S is sigma capital MR delta R is equal to 1 to n. Capital MR is upper bound. Now this capital S is bounded, set of all S is bounded. Infimum of this S is called upper integral of fx, and it is denoted by a to b bar. Now lower integral. Suppose fx is continuous in closed interval AB, small s will be set of all lower sums. This supremum of small s is called lower integral. Lower integral of fx over the interval AB, and the notation is a bar to be fx dx. So pause ಮಾಡಿ. Upper and lower integrals. Now we define what is Riemann integral. Riemann integral. Suppose fx be a continuous function in a closed interval AB, and bounded it is, if lower integral a bar to be fx dx is equal to upper integral of fx a to b bar fx dx, then fx is said to be Riemann integrable, or it is simply R integrable in AB. So how to define? First we have defined what is lower integral, upper integral. For that we required what are upper and lower sums. That we have defined. What are upper and lower sums. Then we have defined what is upper integral and lower integral. Now see the Riemann integral definition. Riemann integral definition. We say that a continuous function fx in a closed interval AB which is bounded is Riemann integrable in AB if upper integral of fx is same as lower integral, and if the function is Riemann integrable, it is simply called integrable. Now here first important thing is, you can say these are notes. First a and b are called limits or bounds of integration. A and b are bounds of integration. Second, the important thing is, here in case of Riemann integration, two conditions are important. First is fx is bounded in AB is closed interval, and AB is finite. These two things are important. Function is bounded and the interval is finite. A and B are called bounds of integration. Now all continuous function need not be integrable. Here all continuous function need not be integrable. We consider some examples here and we apply the definition of this upper and lower integrals and prove that some functions are integrable and some are not integrable. That is in next video I consider some problems. Some Dirichlet's function, prove that the Dirichlet's function is not integrable in any interval AB, and some what is that? Some functions, continuous functions, may not be integrable. Okay, I consider in the next interval some problems and then algebra of integrable functions, and I try to complete this 20 hours topic